item set. List of elements, and each element consists of set of items. So these are the sequence, which consists of 5 elements and 9 items. So it's 9 item sequence. And remember, if the order of the item set changes, then it is not equal. See, A, ABC, AC, D, CF is not equal to A, AC, ABC, D, CF, because the order has changed here. Subsequence and supersequence. There are two sequences, alpha and beta, and alpha is called subsequence of beta if there exists some integer in between 1 and m such that the item in alpha is subset in or equal to items in beta. And beta is called as supersequence. For example, see, this is beta, which consists of elements, and the subsequence is alpha 1, alpha 2, alpha 3, wherein C, A contains in subset or equal to A. Again, the second A is subset or equal to ABC. AC is subset or equal to AC. D is subset or equal to D, and C is subset or equal to CF. So alpha 1 is subset or equal to beta. Similarly, alpha 2 and alpha 3. But if you take alpha 4, D is present in D here, subset or equal to D. C is subset, F is subset or equal to CF. But what about CF? It does not contains any item set in beta such that it is subset. Have you understood why alpha 4 is not subset or equal to beta? Or shall I repeat? I'll repeat. D is subset or equal to D. F is subset or equal to CF. But there is no item set in beta such that CF is subset or equal to some item set. Again, CF is subset or equal to CF. But what about D? You should say, since it is a sequence, you should see the order. ABC is subset or equal to ABC here, and D is subset or equal to D, C is subset or equal to CF, but there is no item set F. The support of sequence alpha is nothing but the number of tuples that contains alpha. So these are set of sequences. You need to find all the frequent subsequences which have the minimum support. So the minimum support is given as 2. So A is there. What is the support of A? Tell me the support of A, anyone? Ma, Vinpisha class, Sai Krishna. I'll go to the previous slide. Again, you answer. The support of sequence alpha is number of tuples that contains alpha. One, the number of tuples. There are 4 tuples, so the maximum support will be 4 only. Is this point clear? 1, 2, 3, and 4. A support is 4. Yes, only once. Your voice is too slow, too low, Sai Krishna. Ah, no, it is the customer ID who is purchasing the same item. The quantity is more. Okay, only once. Tuple. Yes, remember this definition. The support of thing is tuples that contains the alpha. That's all. So consider in this single tuple. Okay. Now, if you observe our solutions, that is frequent subsequences, there is no item or no item set consists of AE. Why we are not including AE? Yes. Okay. Because its actual support is 1, but minimum support is 2. The actual support should be greater than or equal to minimum support. So for finding the frequent item sets, you have different solutions. We have seen a priori based one, okay, and a regular expressions constraint SPRIT one is one of the solution. We are not going to study about it, but just for your knowledge, I have given here. And projection based. Under the projection based, we are learning prefix span algorithm, wherein prefix span algorithm does not generate any candidate items. So, given two sequences alpha and beta, sequence beta is called prefix of alpha if and only if the item bi is equal to ai for all I is less than or equal to m, and bm should be subset or equal to am. So simple thing. See, there is a sequence alpha. Okay. If you take the beta sequence is prefix of alpha a b c a, which is prefix here, isn't it? Of other sequences. Or see, bm means the items that contains in beta is subset of alpha. Then beta is called the prefix of alpha. Is this definition prefix clear?
Yes, ma'am.
Yes. Projection. Again, in this case, you have three sequences: alpha, beta, and alpha dash. Beta is a subsequence of alpha, and alpha dash is also sorry. Alpha dash is also subsequence of alpha. Then a subsequence of alpha dash of which is a subsequence of alpha is called projection of alpha with respect to beta prefix, if and only if alpha dash has prefix beta and there is no proper super sequence alpha double dash of alpha dash such that alpha double dash is subsequence of alpha. Leave about this definition. See, alpha is a sequence. Okay. And if you take beta, beta is subsequence of alpha, isn't it? BC is subset of ABC, A is a subset of AC, so beta is subset of alpha. And alpha dash is also subsequence of alpha. And according to the definition, see, beta is the subsequence of alpha and beta is prefix of alpha dash, which is the subsequence of alpha. I'll repeat. Beta and alpha dash are subsequences of alpha. Okay. And beta has prefix of alpha dash has prefix of beta. Then alpha dash is called as projection of alpha with respect to beta. Is this point clear? What is projection?
Ma'am, can you repeat the projection part?
Okay, ma'am. See, I have consider alpha as a supersequence and take two subsequences, beta and alpha dash, such that alpha dash should have the prefix beta. I'll repeat. Take a supersequence alpha and take two subsequences, that is beta and alpha dash of sequence alpha, and you need to take one of the subsequence such that it should have a prefix which have the subsequence of alpha.
Okay.
Okay, so here beta and alpha dash are subsequences of alpha, and alpha
Yeah.
dash contains another subsequence beta as a prefix.
Yeah, okay, ma'am. Thank you.
And other point, you have to remember that there should not be any super sequence of alpha dash such that that super sequence is subsequence of alpha and has prefix beta. The second point is should also be taken into consideration. Postfix. You know prefix. So again, let alpha dash is a projection with respect to prefix beta, and sequence, there is a sequence called as gamma, is called the postfix with respect to prefix beta and is denoted by gamma and is represented as alpha by z beta, whereas a double dash is equal to am minus a dash. Simply it's saying, see, alpha, when you are take what is beta, according to our previous definition, beta is a prefix and we are representing postfix as gamma. So the concatenation which you are representing with the dot operator, the concatenation of beta and gamma is your original sequence. That is, the concatenation of prefix and postfix is your original sequence. See here, your prefix is, your original sequence is alpha dash, beta is a prefix, A, B, C, A. Okay, and remember, when you are considering A, B, C, A as prefix, A is a part of item set. Okay, so again C is also a part of item set. So when you are representing the remaining part of the item set, you need to represent this C as also an item set, and it shares the space along with other items, and the other items we are taking apart, isn't it? A, B, C, sorry. Here, A, B, C, A. We are considering as beta. The remaining part as postfix. So when you are considering the remaining parts, and C is a part of item set, the remaining items should be represented with underscore. Have you understood? See, in item set AC, A we have taken for prefix. C is remaining, but C is in item set. So the remaining empty part we are representing as underscore. So the concatenation of this prefix and postfix will give you your original sequence. And if I want to represent only postfix, what is the definition? Your original sequence minus prefix will give you your postfix. Any doubts? So prefix span algorithm, you will input the entire database and you will give the minimum support, and the complete set of sequence pattern with that prefix will be your frequent items. The same thing is repeated. Now, this is the example. Okay. Find the length of all one sequence patterns. And I think I have given minimum support, right? Chana? Let the minimum support be 2. Okay. So the actual support of all one sequential patterns are given. Then what is not a frequent item here? Tell me what is not a frequent item?
G.
G, very good. So we are removing G. So all these are one item frequent items. Sorry. One sequential patterns which are frequent. Now with this A as a prefix, the first one, A as a prefix, what are the items you are getting? ABC, AC, D, CF. Next, A is a part of your item set. So underscore D, C, B, C, A. Then here in the second item, A is a prefix. So from that the remaining part will be written. So B, D, F, C, B. A here prefix. So underscore F, C, B, C. Is this clear? If this is clear, I'll go with B.
Ma'am, the prefix arrow pointing to A, ma'am, the table
Yes.
which is there, right, ma'am, that is the value of gamma, right?
What is gamma here? We are. This is prefix span algorithm, not postfix span algorithm. I have given the definition for postfix.
Ma'am, but this is also equal to gamma, right?
Oh,
In a way.
what you are saying? This A, B, C, A, C, D, C, F.
Yeah, ma'am.
Yes. Yes. Okay. Right.
These are gamma values, no, ma'am?
You can consider it as gamma value, but when you consider gamma value, you need to consider, see, in this sequence, for example, if I take A as a prefix, D, C, B, C, A, E will become gamma. Okay?
Yes, ma'am.
But E, F, A, I am not considering as prefix here. I am considering only A as prefix. E, F is ignored. Okay? And the remaining part B, D, F, C, B will be my frequent items here. Or I will consider these items. But if I am saying A as prefix, and if I say, for example, B, D, F, C, B as postfix, and when I concatenate the prefix and postfix, I want to get my original sequence.
Yes, ma'am, I got it. Yeah.
Then, okay?
Yes, ma'am.
So I am ignoring EF and A as a prefix. I am writing all the remaining items here.
Okay, ma'am.
Okay. Any other doubts?
No, ma'am.
Other candidates, other students. Any other doubts? Any doubts? So similarly, B as a prefix. I'm writing the remaining items. Once you consider all this, then I'll move to further. The same thing. Have a look at prefixes B, C, D, and E, F. I'll move further. Right. So now I'm considering this D, and you need to write all the prefixes for A, B, C, E, and F. But as of now, I am showing only D. One minute. So D contains these things: C, F, C, B, C, B, C, A, E, and F. So all one items A, B, C, D, E, F, and underscore F should also be considered because it is a part of item set. So which are not meeting my minimum support, that are deleted. So in this D as a prefix, what are the frequent items we'll get? DB and DC. So the frequent items with the two items are DB and DC. Is this clear? Okay, I'll proceed. So now take DB as a prefix and DC as a prefix. See, these are all frequencies. You can stop at any level. These are all frequent items. If you want to stop here itself, you can stop. But I'm proceeding further. So DB and DC are prefixes. So DB and underscore C and A. And what else? DC na DC. So I am getting DC, BC, and AE. Okay, right? And the remaining item B. So here, here itself, I can able to know that the minimum support criteria is not satisfied here because only one tuple is there. Huh? Chapama. D lo CF, so DC కింద F పెడతాను అంటావు. F ఆల్రెడీ పెట్టిన లాభం లేదు కదా, తీసేసాను కదా, ఆల్రెడీ వన్ ఐటమ్ సపోర్ట్ కింద వచ్చేసింది కదా. Shall I proceed? Okay. So here a single tuple, no need to consider because support will get only one query. Okay. So I'm eliminating this. Here B, C, B will get 2, A, E, C, and 1. So everything will be removed. Its final 3 items frequent sequence will be DCB. Again, if I want to check, nothing will be there. Okay. So you can stop at any level, and these are what you are getting are the frequent items. So when you are a priori algorithm or a general type of general sequential pattern algorithm, this is more faster when compared to the previous algorithms. Sai Krishna, are you recording? So prefix span algorithm is efficient growth method. Cost of prefix span in the construction of projection database. So to reduce the cost, different projection methods are used with additional knowledge. We are not going to discuss what is bi-level projection, pseudo-level projections. So as prefix span algorithm is incurring more cost, we are going for a modified projection methods, that is bilevel projection and pseudo projection. So generate sequential patterns. If you have observed that in classical sequential patterns, we are not generating the rules. But we can define the rules. Here we'll discuss 3 types, which is used in web usage mining and web content mining, that is sequential rules, label sequential rules, and class sequential rules. A sequential rule, which is of the form X associates Y, where Y is a sequence and X is a proper subsequence. So X is a subsequence and Y is a super sequence. That means that the length of Y is greater than the length of X. So what you understood here? So we can generate a rule if X is a subsequence and Y is a sequence. And the support of sequence rule is in a sequence database. S is fraction of sequence in S that contains Y. So we are calculating the support of Y here, and the confidence we are calculating for the entire rule. So given a minimum support and minimum confidence, according to the downward closure properties, all the rules that generate these frequent sequences can generate this generate this frequent sequence without going to the original sequence. That means you are checking the minimum support and minimum confidence according to the downward closure property, because you have subsequence and sequence. Let us see the example here. These are data sequences. Okay, and when you observe here, 1378 is a sequence and 17 is a subsequence of 1378. And how you calculated this support? Total out of 5 sequences, 2 sequences 1378, 1378. 2 sequences contains Y, the conjugate. So you'll calculate support for the conjugate. But whereas confidence, you'll calculate for entire conditions. So out of 17 is there in 3 sequences. So denominator at 3, and 137 contains in 2 tuples, that is 2 by 3. Label sequence. Label sequence rule is very easy. Label sequence rule of the form X associate Y. Similarly, where Y is a sequence and X is a subsequence, and X is a sequence produced from Y by replacing some of the items with wildcard. I'll go with the previous example, the previous one. What is a label sequence? Label sequence is a sequence where X is produced by replacing some of the items in Y with wildcard. See here, what is Y? 1378 is Y. X is 17. So X is produced by replacing some of the items in Y. So I am replacing 3 with star and 8 with star. So if you observe, the confidence has changed here. Previously here the confidence is 2 by 3, and I am replacing it with the wild card. So the confidence has become 2 by 2. Is a sequence, label sequence and a sequential rule. Any doubts? Anyone?
No, ma'am.
Class sequence rule. Similar to your car. Okay. So here the sequence contains a class label and it is of the form sequence, comma, class label, where and is x associates y, where x contains the sequence and y is a class label. So this is the example where all the sequences contain some class label, and in our example you have only two class labels, that is C1 and C2. So the sequence is associated with one class label. So you are writing the rule with as sequence and the class label. And yes. This is end of your first unit. Any doubts in your first unit? I think no one have doubts in first unit. So we'll move on to your second unit. What is the second unit? What is your second unit? Very good. Prepared PPTs for second unit I have not prepared any PPTs and I simply downloaded from the net. Can you able to see this PDF? Right. Supervised learning. Supervised learning is also called as supervised learning is also called as classification and inductive learning in machine learning. Say why supervised learning or why classification is required. So let us try to understand about classification with this example. Now there are too many patients and all the patients cannot be accommodated in the ICUs, right? Now there are too many patients, COVID patients are there, and you cannot place all the patients in ICU. Then based on some of the attribute values, that is according to the pulse level, breathing levels, or BP levels, the patients are placed in ICUs. Okay, so here based on the attribute values, that is his temperature, breathing, pulse rate, you are deciding an attribute called as whether the person is critical or not. Okay, that critical or not is a class label, and based on the class labels you are taking the decisions. That means based on the that class label you are classifying a particular patient, that whether the patient has to be kept in ICU or not. Okay, this is the need for classification. You are classifying the patient according to the class labels, and the class label values are in turn decided based on your attribute values. Yes. So let us take the second example here. Whether an applicant has to be allocated or has to be given the credit card or not. His application has to be approved or not are decided based on the attribute values like age, marital status, annual salary, and so on. So you are classifying the applicants here whether to approve his applications for credit card or not. So how you will decide this? If you are humans, you learn from past experience. But the machine is not human. But from where it will learn? It will learn from the data. It will learn from the past data. So what is our focus? Our focus is to make the machine to learn and make your predictions, or the system, sorry, manam kadu, the system has to make the predictions based on the learnings that it has learned from the previous data. So this type of task is commonly called as supervised learning. Association, you don't have to, in associations there is no learning, but in classification there is a learning. The system will learn from the past data and predict the future. Previously I said that the instances in web mining terminology is called as observations or examples. Mainly we use the word examples here for the record. A set of data records described with attributes, k number of attributes, and a class label. So the goal of classification is to learn the classification model from the data and predict the classes for new examples. Take the screenshot of this data. Done? Because we are going to work on this data only. Take the screenshot of this data. Shall I proceed? Shall I proceed? So this is loan applicant data. Okay. So we have to learn a classification model from the data, and we need to decide whether the application is approved or not approved. So we have a future data like this with age young and has job false, so on, and we need to decide the class label for this observation or example. Supervised learning and unsupervised learning difference. What is the difference between supervised learning and unsupervised learning? Yes, class labels. Class labels. That means we'll classify the data with respect to class labels. But here in unsupervised learning, as there are no class labels, we classify or group the data based on the వినిపించట్లేదు relation between the data, that means based on the similarities. Supervised learning has two steps. First of all, when you have a data, the data is divided into two parts: training data and test data. And when you are dividing the data into two parts, that is training data and test data, you need to remember one thing. What is that? The data should be identical. What do you mean by data should be identical? See, these topics are just a repetition of your data mining. See, when you are reading the same thing, apart from the association law, you have learned the advanced topics like car and sequential pattern mining. If you see this classification, the same thing is repeated. Then what is the difference you are finding in data mining and web mining? The same repetition terms you are reading. My difference ఏంటి? ఫస్ట్ యూనిట్ లో చెప్పాను. What is the difference? Data mining, web mining లో. The same thing. Here also you are learning based on the structured data, and there also you have learned structured data. Then what is the difference? Same topic, same definition, same data. Then what is the difference? మీ total strength 21 Sai Krishna. Okay. ఎవరు absent? తన పేరు మర్చిపోయాను నేను. సర్లే. Tell me what is the difference? నా పిపిటి కనిపిస్తుందా? PDF. Can you able to see? Yes. The difference is there. The only difference is there you are getting the data from data warehouse, but here you are getting the data from the web. Once you retrieve the data from the web into your local systems, everything is same. That's why the concepts are repeated here. In data mining also, in the data warehouse data, you are not applying all these algorithms. You are retrieving the data from the data warehouse into your local system and you are applying the algorithms. Similarly, here also you are retrieve the data from the web and apply the algorithms. This difference is from where you are getting the data. But web data unchi you can apply your algorithms sometimes. But what happens if you apply the algorithms in the cloud or web or in the internet? What is the difference when you retrieve it in your local systems and apply the algorithm? And what is the difference when you apply the algorithm in the internet itself? Dynamically changing annappudu algorithm change kaadu. For example, if the data is static, for example static pages retrievals hyperlink ni retrieve chestunnavo unna static pages lo PDF lo kaani dentlo kaani, then what will be the difference? Say dynamic pages ni marchukondi. If the pages are static, you are applying data mining algorithms kada. You may clear noisy data and you may apply algorithms only for the needed one. Sorry, I don't want to drag more. Performance degrades. There you need more CPU kada, more time. When you are applying to local systems, it will be more faster. The performance degrades when you apply your algorithms which is in internet. That's the reason why we'll retrieve the data into our local systems and apply the algorithms. Right. So, what do you mean by identical? Identical means that the class labels should be equally distributed in learning, in training data and as well as in testing data. That means that if you, I have 3 class labels, and your training data consists of all 3 class labels C1, C2, C3. If your training data consists of only C1 labels and testing data consists of C2 and C3, then the resultant may not be that much appropriate, or you will get wrong results sometimes. And if you are even the training data, if you contains more number of C1 class labels and only one of C2 and C3, then also you will get wrong results. The distributions of the class labels should be equal. And repeat. Now it is clear. Now, okay. Shall I repeat what I said? The data should be equally distributed, especially the class labels. Do you want to repeat me entire thing, or shall I proceed? No doubts. Okay. So, supervised learning process consists of 2 steps, that is learning phase and the testing phase. So, based on the training data, you learn a model, and then the model is tested on the testing data, and the accuracy of the model is calculated using a measure called as accuracy, where accuracy is given by number of correct classifications by number of test cases. I think మీరు ల్యాబ్ లో వెకా యూస్ చేశారు కదా. మీకు ల్యాబ్ డేటా మైనింగ్ లాక్డౌన్ స్టార్ట్ అయిందా? ఓకే ఓకే. ఓకే సరే, అంటే ఎలా అక్యురసీ వాల్యూస్ వస్తాయి అవన్నీ చూసారు కదా పక్కన. So what do you mean by learning? See, without learning with respect to machine. See, without learning something, I have given some result. That without learning, the system or the user has given some result. But now, based on the classification algorithm, the system has learned something and given some result. Okay, if that result is more or if that result is an improved result when compared to the result of without learning, then we can say that the system has learned something. ఇప్పుడు సింపుల్ గా ఒక విషయం చెప్తున్నాను. మీకు ఇప్పుడు ఎగ్జామ్ పెట్టారు, ఓకే, అండ్ ఎగ్జామ్ లో మీ రిజల్ట్ సే సంథింగ్ ఎక్స్ వాల్యూ ఈజ్ యువర్ రిజల్ట్. After that X result, that means that you have failed in that examinations. That means you have not learned anything. But after supply exams, again you have learned something, or book mundeskoni edo chadukunaru, and the result is not improved. Then can I say that you have learned? No. When I can say you have learned, if the results before supply and after supply are improved, the result of after supply is improved, then I can say that okay, this particular candidate has learned something and given examination and he or she has passed. When you are learning something, the result should get improved. Then only you can say that it is learning. Right? So a computer system is said to learn from D to perform some task is if after learning the system, the performance of the task should get improved. Then only you can call that as the system has learned. Is this point clear? Yes. So, do you have that screenshots of of the data given? Yes. Now, by seeing the data, these slides already sincerely tell me by seeing the data, I have given what is this? This is the new observation. What is the class label? This is the new observation, and you decide what is the class label.
Class label is no.
Why no? Why no?
Ma'am, because the same values have been given in the second row, ma'am.
Second row same value ichera. Okay. So if I slightly change some of the value, either slight change which is not there in your data set. I have changed some value here or somewhere one of the value which is not there in the data set. Then what value you will give? What class value you will give? Assume that these values are not there in the data set. Some value has been changed. So in that case, what class value you will give? Have you understood my question?
Yes, ma'am, understood. But I don't know, ma'am, what value to give.
Most probably, you will give the value which has more class values.
Okay,
So
ma'am.
most of the students, sorry, most of the applicants has got S value. Obviously, you will give S value to this. Whichever is dominating, that value you will give.
Okay, ma'am.
If that particular observation is not there in your previous data, obviously you will give whatever is the more, that value you will assign to this. Okay? This is
Yes.
without learning. Without learning, whichever may be the highest value, the S value is 9 out of 15. So 60% is S. Obviously, you will assign S to that new observation. Okay, this the result, whatever is there, can be improved with learning. Is this point clear?
Yes, ma'am.
Right. So when you are going with classification problem, the main thing is you'll make an assumption that say when you are using the tools for classification separately, you won't give the as a training data and the testing data. Sometimes you may give if you are writing your own algorithms. So the system randomly will pick the data and it itself will divide the data into training set and testing set. So here when you are doing the classification problem and you are randomly picking the data using the tools, You are assuming that the distribution of training data and the testing data are identical. This is the main assumption you are making. But sometimes this may get violated because you are randomly picking. So if the violation is strong, you will get poor classification accuracy. So to achieve the good accuracy on test data, training examples must be sufficiently representative of the test data. That means the training set and the testing data should be identical. That means the data should be equally, the class labels inside the training data and the test data should be equally distributed. Decision tree, the next topic, I'll stop here. Any doubts?
No, ma'am.
Right.